Hi, this is Alex from devstories.eu. Biopython Fundamentals, Episode 8 of 18. Staring at an auto-refreshing web page while a sequence aligns against a global database is a terrible use of your afternoon. Automating that search in the background means you can do something useful while Python does the waiting. Today we are covering running BLAST over the internet using Biopython. The function you need is called qblast, located in the bio.blast.ncbi www module. It acts as a wrapper around the NCBI BLAST API, allowing you to submit queries directly from your script exactly as you would through their web portal. To trigger a search, qblast requires 3 mandatory arguments. The first is the BLAST program you want to execute. For example, if you are comparing a nucleotide sequence against a nucleotide database, you pass the string blastn. If you are working with proteins, you pass blastp. The second argument is the specific database you are searching against. The most common choice for nucleotides is the string NT, which stands for the non-redundant nucleotide database. If you are searching proteins, you would use NR. The third argument is the sequence query itself. Biopython makes this input highly flexible. You can provide a plain string of the raw sequence, a multi-line string formatted as a Foster record, a Biopython seq record object, or an exact sequence identifier like an NCBI accession number. If you want to run a basic search, you call qblast, give it blastn as your program, nt as your database, and your FOSTA string as the query. Python will pause execution here while it negotiates with the NCBI servers, waiting however long it takes for the remote alignment to finish. When the remote server finishes the job, qblast returns a file-like object containing your results. Under the hood, the function requests these results in XML format by default. You should ensure it stays that way, because XML is the standard format Biopython relies on for downstream processing. Here's the key insight. Do not immediately pass this returned web handle into a parsing function. Running a remote BLAST search is computationally expensive for the NCBI servers and time-consuming for you. If you parse the live data stream directly from the web handle and your script encounters an error a few lines down, that sequence data is lost from memory. To fix your code and try again, you would have to execute the exact same remote search from scratch, wasting their bandwidth and your time. The correct workflow is to permanently save the raw output immediately. The moment qblast returns the web handle, use standard Python file operations to open a new local file in write mode. Read everything out of the web handle, write it directly into your new local XML file, and then close the web handle. You now have a safe, static copy of your BLAST search sitting on your hard drive. You can open that local XML file tomorrow, next week, or 50 times in a row while debugging your application, without ever pinging the NCBI API a second time. Always decouple your network retrieval from your data processing by writing web responses to disk first. That's all for this one. Thanks for listening, and keep building.